Hi, it's me, Jazzy. I'm back with another tech-related video, and today I'm taking a look at a very unique and useful product. It's a multimeter, but it's also a thermal imaging camera, and this is the Tooltop ET15S. Now, many thanks to Tooltop for sending me over this review sample for me to take a look at. I'm really looking forward to getting to grips with this, as thermal imaging camera is a really useful tool for fault finding in electronics. You want to see if something's getting really hot, then this is absolutely brilliant for doing that. Now, you've seen me previously using one of these infrared thermometers, which is a great option. But if you can get your hands on something like this, it's going to make your life a lot easier. So it's a 256 by 192 thermal imaging camera, but it's also a 199.99 count multimeter with an analog needle display and a waveform visualization. It's got a macro lens and a temperature range of -20 degrees C to 550 degrees C. It's powered off a lithium battery, which gives you 8 hours of runtime and is USB rechargeable. So let's dive in and see what's in the box. Now, I've been waiting to get my hands on an infrared camera for ages because they are super useful in fault finding. So it comes in a nice case by the look of it, and we've got some instructions and some more instructions. Great, multilingual instructions. All looks very detailed for how you set it up. Okay, excellent. Take a look at that in a sec. What do we get inside the case? I like the red trim, very smart. Okay, very nicely packaged. So we've got the multimeter itself, and we've got some accessories. Got some probes, and you've got your USB charging cable in there. And it looks like they've given you a spare fuse as well. Right, so let's open this up and have a look. Sealed for freshness is always good. Right, here we go. The Tooltop ET15S. So it's got a 3.5-inch screen. It's got like this ruggedized rubber bumper around the outside. I'm not going to say baby buggy bumper because I can't say that. I've tried. Your probe connections are on the front there. You've got a standard tripod mount on the base there, so when you're using it in camera mode, you can mount it securely. It has got a stand on the back there, and you can see this version's got the macro lens, which is why it's going to be so good for looking at electronics. You just slide that across and you can look really close up. So if you want to look really close up at a component to see what's getting hot, you can do that, and then you can move that across and you can use it as wide angle as well. Right, let's get this on the bench and take a closer look. It does look really nicely made. I do like the ruggedness of this. Right, so we can see we've got our kickstand on the back here, which is nice. Nice and solid on the bench there. That's not going anywhere. I think even if you knock that, it's not, because of the unique shape of it. And these feet are non-slip, which is good. I like that. Okay, so on the side we've got an up and down control. We've got our charge port under here for the USB-C recharging, which you do get the charge cable with this. You've got your on-off on the side there, so let's power this up, shall we? Oh, there we go. IR camera multimeters. Okay, loading. We've got a proper operating system on this. Okay, doesn't take long to load then. Straight away, the hottest thing in here is going to be my power supply. So let's have a look. Wow, that's really good image quality. Of course, the advantage on this, you've got that macro lens. So if you just slide that across, then you can get really close in. That's amazing. We're going to try this out on some surface mount components. That macro lens is going to be a real advantage on this. I'm going to do my standard test with my power supply. I'll put this thermometer up here with the thermistor. Go and give that a sec. Right, so let's have a look. Straight away you can see that's a really nice quality image. That's going to make it so much easier to see where the thermistor is. And you'll see occasionally it comes up as calibrating. It's calibrating itself every so often, which gives you the most accurate reading. Okay, so in the center I'm getting what, 37.2, 36.9, about 30, high 36, low 37s. Yeah, that's pretty good. Of course, you've got image capture on here. Just press the save button. Screenshot saved successfully, and you can hook it up to your PC with the USB-C cable that's supplied to get the images off. Let's see if we can get one with the macro lens. Look at those terminals. That is amazing, the amount of detail. Look, you can even see the dirt on the contacts there. So we've got 4 multifunction buttons on the front here. So the first one will swap between infrared camera and multimeter. We'll take a look at the multimeter in a bit more detail in a moment. But a long press on that will take you into the menu, and you've got absolutely tons of stuff in this. We'll run through that in a bit. This button exits. We've already seen what the save button does. It's also the hold button when you're using the multimeter as well. This will change your range for your multimeter functions. A long press on here will also turn the flashlight on, which you've got on the back there. Very convenient. So you've got a 3.5-inch screen on here, so you've got plenty of room for a decent size image and loads of information. So you can see you've got all your temperatures here, your center temperature, your max and your min, and the difference between the max and min temperatures. You've also got your color scale here, which shows your high and low temperature. You've got your current time, your battery level, your SD card is shown there. Down the bottom here, you've got the distance of measurement and your emissivity, and you've also even got some multimeter display down the bottom at the same time as the infrared display. So the screen on this is excellent. It's a 3.5-inch IPS screen. The screen resolution is 320 by 480. So it gives you a nice clear image. Of course, the thermal camera on here is 256 by 192 resolution, so you're getting a really good resolution. You can really see the detail on this image. So you've got 15 different color palettes on here, which you can use the up and down buttons on the side here when you're in thermal image mode. Long press on that will change. So you've got a black and white mode. Look how clear that image is. Wow, I can't get over that. Let's put the macro on again. Look at that. That's astonishing. You can see all sorts of dirt on the contacts that I didn't actually know was on there, to be honest. Of course, you switch out of the macro, you get a really clear image from a distance as well. So let's try some of the other color palettes then. Okay, so we've got inverted. Okay, so you've got quite the range there to choose between. There we go. Amazing. So I reckon this infrared camera is going to be super useful in fault finding. So we've got an old CD player here which is powered up. Now if we have a look at the board there, you can see we're getting some good detail on there. Now you can see there we've got some heat there. So if we switch the macro lens in, this is where this comes into its own now. Now we can get in really close. Look, you can get right in on that voltage regulator. It's looking rather toasty there inside that heatsink. A couple of other components there that are looking a bit on the toasty side. So then you can get right in and see what they are. We've got a rather warm looking transistor down there. Because of this macro, we can get right in there. Look, that IC is starting to get hot there. You can see it so clearly. You can see the Sony name on it. We've got a rather hot little resistor down there. Even at a glance, you can see where the components are getting hot. There's obviously always going to be areas where you expect them to be getting warm, but if there's anything suspicious looking, it could help you with your fault finding. But we can have a look now, and you can see there is a few components here getting warm. Let's go again to macro mode. Obviously we don't want to get too close to them, but that is close enough. And that's clear enough that you can see exactly what those components are that are getting hot there. And again, just because they're orange or yellow doesn't necessarily mean they're too hot. It just means that's the hottest part of that area that you're looking at. So that in the center, 45 degrees. And let's have a look on this little diode here. Yeah, 44 degrees. Okay. We've got a little bit of heat down here on these two resistors. Now let's have a look at the power transistors. Wow, yeah, you can see, look at the detail you can see on the heatsink with the macro lens. Right, so let's have a look. So this is a faulty laptop here. So let's have a general look then at what's getting hot on this laptop. Well, that's obviously where the power's coming in. We've got a couple of ICs here that are getting a little bit warm, but you can see the processor starting to warm up now. So this is where this should excel itself, macro mode. Because of the macro lens, you can get right in there and see what you're doing. Because this has got the resolution, it's 256 by 192 resolution infrared camera, you can see so much detail. You can see all the detail of what's getting hot. And you're getting that constant temperature readout as well. Because it self-calibrates, it's always trying to give you the most accurate reading possible. So you can look at the board first in wide angle mode and identify where your areas of heat are. And as I say, obviously some of these areas of heat are going to be natural, but if there's anything looking out of place, you can use that in your fault finding. So you can see in general terms where the heat is, and then just swap to the macro lens. There you go, you can get right on in there, look at that. And that's telling me down the side that the hottest area is 61 degrees, and that's the whitest color. So where you're seeing that white heat, which is probably over where the power's coming in there somewhere, is going to be the hottest. And you can see that that goes down to 17 degrees on the darker areas, which are not hot, which is like off the side of the motherboard there. So all the time that's giving you those temperatures constantly up in the corner there. So your center temperature, your max, your min, and the difference between the center and the max and the center and the min. And of course, you've got your emissivity down the bottom there, which we've looked at emissivity before on the channel, but we'll take a look at that in a moment once we get into the menus, because there's a lot of functions on this and there's a lot of things that you can tweak. And then you can just cycle through your color palette as to which one works best for you, which shows up the problems best to you. Do you want the hot areas highlighted in red like this, or do you prefer more of a monochrome, or the more traditional yellow and white heat? Everything just looks so cool under infrared. When you're trying to fix something like a laptop or a motherboard, there's obviously going to be a lot of components that could be a problem. And having an at a glance like this, and you can take a snapshot and refer back to it, I think that's actually really, really useful. Okay, so let's take a look at the menu. I said we were going to take a look at this in a bit more detail. And you have actually got loads of stuff in here. So you can see there's the SD card. It tells you it's 3.7 gigs. So if we want to have a look at that, then we just press this one here, and there you go. There's all the images that we've taken earlier, and these are all the VOM files. So these are the waveforms and measurements that we've recorded from the multimeter. Now we'll take a look at those in a moment, because there's a way you can open those on your PC and make a graph. Okay, you can change your color palette there, which we looked at earlier. You can change your emissivity, which we've looked at emissivity before on the channel. Now that's to do with the type of material that you're measuring. So if you want to change your emissivity based on what you're measuring, you can go in there, and you've actually got all the categories listed. So depending on what you want to measure, so we're on 0.95 at the moment, but you can change it. So PCB, they recommend 0.91. So to get a more accurate result from your temperature measurements, you can change the emissivity to match what you're measuring. And because it's got all the types listed down the side there, that's pretty easy to change that. So let's come back out of there. You can change your measuring distance. That's set at 0.3 meters at the moment, but you can change that. You've got your display parameters, so you can select what you want on the screen all the time. So you can turn certain things on and off depending on what you want on the screen. You can change your temperature range. Now that's quite handy, again, to give you more accurate readings. So if you go into there, you can switch. You've got your low temperature range, which is -20 to 150 degrees C, or your high temperature range for 100 to 550 degrees. You can select your temperature unit, centigrade or Fahrenheit. That's your digital multimeter, your start gear. They call it gears, it's not actually gears. Let's not get into what's gears and what's not gears. So you have a start gear here, so you can, when you select multimeter mode, you can tell it which mode you want it to start up in. So depending on which one you're going to use the most. See, I did tell you there's a lot of things on here. You can turn the waveform on and off. You can turn the sleep mode on and off. You can change your boot mode. Again, there's loads of options. I won't go into all of them. A lot of them are self-explanatory there. You can change your backlight, the sound volume. Automatic shutdown. You can change the time, how long until it shuts down. So at the moment it'll shut down after 10 minutes, but you can turn that off if you're doing a long session of repairs or tests. Change the language, factory reset, all pretty standard. Format your SD card, and there's your USB mode if you're hooking it up to your PC, so you can get your images and your VOM files off as well. Of course, you can also do your firmware update. So there you go. As you can see, there's loads of options in the menu, and that exits there. Back to the thermal camera mode. Now, short press on here will take us into multimeter mode. Hooray! And we've got, again, loads of stuff. So your multifunction buttons here, it'll give you a little header here of what it's going to do. You can also see you've got a graph down here, you've got a needle display here, you've got loads of stuff, some of which you can turn off in the settings if you find it's a bit too much. So let's hook up some probes. Right, so these are the probes that are supplied. Got little covers on the tips there. So let's hook these up, shall we? Protective caps on them as well. Look at that. Right, so let's hook this up. I'll do a few little tests on this. I won't go through all the functions or we'll be here all day because it has got quite a lot. So on the side of the ET15S, you've got these up and down buttons here. Now, this is what we were talking about when it says shifting gears. You're not actually shifting gears. There is no cogs in this. Shifting gears, you've got this little sort of rotation here. You can see going round now of the different functions. So you can just scroll round. Resistance, current, voltage, non-contact voltage, temperature, frequency, resistance. You've got the continuity beep. So let's try that. Okay, it's not instant. It's not bad. Not the fastest I've seen, but it's okay. If you just tap it quickly, it doesn't pick it up. It needs a sec. Yeah, not the fastest for continuity, but it gets there. All right, let's look at resistance. I'll bring in the decade box. This is my H.W. Sullivan resistance decade box. It's old, but it works well, a bit like me. We're going to need some test leads for this. Now, of course, this is not a serious test. I'm not benchmarking this meter. This is definitely not a benchmark. This is a benchmark here. I must give it a clean at some point. So we're just literally testing the functions of the multimeter. How easy it is to use, how quickly it does the measurements, and is it reasonably accurate or not. All my decades are set to 0. We have a little bit of residual there. Now, for all you REL fans out there, I will take it down to 0. There we go. Okay, 1 ohm. Okay. It takes a second to think about it, doesn't it? Yeah. It gets there. It just takes a little moment to get there. 100 ohms. There we go. Beautiful. Now, there seems to be a limitation there that if you rail out the cables, it takes you out of auto mode into manual ranging mode. You can manually change the range, but if you have it on auto and you go up to 1K, yeah, it will sort itself out. Okay, so you can have it on auto or you can have it on manual ranging. All right, that'll do for resistance. Let's try some capacitance then, come on. So this is another H.W. Sullivan. This is a stable mica condenser. So we're going to use this to check capacitance. It's a little bit overkill, but it's a bit of fun, isn't it? We're just literally testing how easy is this to use on multimeter mode, and how quick is it to do the measurements. As we've seen, sometimes auto-ranging multimeters can take a while to think about things. All right, so let's go for 10 nanofarads. Okay, it takes a sec to think about it, but you know, it's not bad. I quite like the little needle gauge. That's quite cool. You've got this graph going at the bottom as well there, which if you save, hold that in to save that waveform, we can take a look at that. All right, 100 nanofarads. Yeah, all right, pretty quick. 500. Okay, 0.50 microfarads. Let's go 1 microfarad. Okay, there we go. So that's auto ranging and it's picking that up quite nicely. So a couple of caps here I'll be using just to test out some multimeters. That's just a 4.7 microfarad. Nothing special. Yeah, that's absolutely fine. What I've got here is a 10,000 microfarad. This has come out of something random. It's just because I noticed some of the meters that I've been using won't pick this up. Okay, picking it up as 9.797 millifarads. Okay, so yeah, it will go to that range. That's quite nice. Got non-contact voltage, quite useful. There you go, it's telling me there's voltage there. Put it near anything with a bit of voltage in it. Picks that up. Temperature, we've got frequency. We can try some frequency with it. Why not? Right, let's plug that in. So let's start with 100 hertz just for a quick test, shall we? Pretty good. All right, let's try 10 hertz, shall we? Okay, yeah. All right, how about 1 hertz then? Yep, there we go. All right, let's go up, shall we? Let's go 10 kilohertz. Will it do it? Yes. Go on then, how about 100 kilohertz? Nice. All right, let's push the boat out and go 1 meg. It does, yeah. Not bad at all. Okay. All right, that's cool. Let's check out some voltages. So yeah, it's got other functions going for it. You can do AC and DC current. It's got live line detection. It's got a lot of functions. I'm not going to go through them all, or we will be literally here all day. But I think the main reason you're going to be looking at this really is for the thermal camera, which as we've seen is pretty awesome. Let's do a quick test anyway, just to see how it picks up on these voltages. So yeah, okay, good. 2 volts, pretty good on voltage. It's fairly quick to react. So one thing I will note, it's quicker on some functions than on others. 10 volts. Okay, there we go. It's accurate enough. It's reasonably quick to react to the changes. So I think in terms of the multimeter, you've got a lot of functions on this, but I think you're primarily going to be using this for the infrared camera. That is the jewel in the crown, but it's still a pretty capable multimeter. So one last thing to look at then is when you hook up the ET15S to your PC, so you can get off your bitmap images and have a look at your VOM files, which gives you all the information from your multimeter readings. Let's have a look at how we can import those into Excel and make them into a graph. So when you connect the ET15S, it opens as a USB drive. You can see it's opened as drive G on my computer, and you have all of the images that you've captured from the infrared camera, which is brilliant. You can open those and you can have a look at them. There you go, opens up and you can see you've got a nice quality image. You can actually zoom in quite a way on there and that looks pretty good. You've got all the information, all your temperatures are there and everything, which is great. So if we come out of that, so you can see that you can view all of your images there, and we've captured quite a few so far. Here's the motherboard we were looking at earlier. Right, and you can see you also get these VOM files. These are the exports from the multimeter. So the idea is you can open those in the software that's mentioned in the instruction manual. Now, I did find the software. I couldn't get it to work on my particular version of Windows. Your mileage may vary depending on what operating system you've got installed, but there's an easy way to look at these VOM files. What you need to do is you need to open it with Excel. Right, so I've opened my Excel. So if I have a look at this one, for instance, Wave 2, and what I've done is done fixed width and finish, and that's all the data. You've got all the data there, but it looks pretty meaningless at the moment. So what you want to do is go to create chart, and then you get a selection of different options there that you can use depending on what chart you want to do. I want to go with just the standard graph because that represents what you see on the multimeter, and you can see there you've got your graph there. It's got all your data and what it was you were measuring. When it saves the files, it doesn't really name them. It just gives, like this one is wave 0002. So it's worth renaming that file something meaningful. But what it means is you have got that representation. So if you do want to look at the data from your multimeter in graph form, that's one way of doing that, just using Excel. Well, there you go. How to make a graph out of a VOM file that you get from your multimeter. Who knew? Well, there you go. The Tooltop ET15S. It's got a lot going for it. It's an excellent infrared thermal image camera that you can use in fault finding. I think the macro lens on the back makes it really useful because you can get right on in on your PCB. Even if you're doing surface mount stuff, you can get right on in there and see what you're doing. So I think as far as thermal imaging goes, I'm really impressed with it. I like the size and resolution of the 3.5-inch screen, and of course having that 256 by 192 resolution for the thermal imaging camera means you get some really clear images. So it's really useful for fault finding. But I think the macro lens, where you can just slide it across and get really close in on the board, that really does it for me. If you'd like to pick one up for yourself, Tooltop have very kindly sent me over a coupon code for my viewers to use. You can get an additional discount of £5 on the product, and it's valid until June the 30th. I'll pop that down below, and I'll pop the link in the video description down below for the Tooltop AliExpress store. And many thanks to Tooltop for sending this sample over for review. I hope you've enjoyed taking a look at this infrared digital multimeter with me. I'll be back soon with some more tech related videos, but in the meantime, take care and I'll see you on the next one.